All right. So, in the presence of small amount of bromine, cyclohexene undergoes the following light-promoted reaction. And again, remember that the light-promoted, high-energy light, typically indicates some sort of breaking dissociation of a bond, free radical sort of mechanism, okay? Okay, and so let's propose a mechanism for this reaction. And so again, the thing you've seen the most of is the BR. You hit it with some high energy light, HV, that's what that means, high frequency. And the BRs do what? Disassociate. So you already got the first part, good. You dissociate the BRs, right? Okay. So the next part of this is going to be, well, what happens when you disassociate this BR? Yeah. They have free radicals, exactly. And then what do they typically do? Yeah, they react to a hydrogen away, right? Yeah, perfect. Okay. And so the next part you need to do on this is you know the position because it tells you, doesn't it? Yeah, that's probably going to attack that position, right? And so we have a Br free radical. We look for a hydrogen that's next to the double bond, but not on it. See that? That's that alpha position. Okay. Notice that we have rearranged our ring. We've rotated the whole ring, haven't we? Okay? Do you see how this is the same, though? It's a symmetric position. Yep, as long as it's that alpha position, the one off the double bond. Okay, and then we attack. Don't forget they're single arrows, right? You may need to cycle through them to get the bond to show up right. But, so you'll take one electron from the bromine, that free radical one. It'll go into a bond with the hydrogen, and the electrons come from that bond between the hydrogen and carbon. That electron's going to stay behind on the carbon. That will give you a free radical. You got it. Free radical on the carbon. Perfect. Yep. And so the next thing is, yeah, we have an HBr that forms. We don't really need that for the other parts of the reaction. They're not really important for the mechanism because that's a gas and it will go away. Okay. But the next part is your carbon-free radical now. That's this right here. It's then going to react with a Br2, like we saw in the previous example. Yep. And again, that's going to take one electron from the Br2 bond. It'll form a new bond between the Br and the carbon. And then the other electron from that bond goes on to the other Br, making another bromine free radical, or bromide free radical.
Would this kind of be propagation kind of?
Yes. It is indeed. Yep. This is actually both steps. So this is the initiation reaction right here. And then you're doing the propagation reactions here. Okay. And then that's just the product. Yeah. Fair enough? Yeah. So that makes sense?
I don't know if the free radicals, I'm understanding it slowly, but I think I got it.
Okay, and do you guys know why this, well, you don't need to know why in this case because it tells you which one it goes after. But this is the major product because it's next to the double bond. Remember where you did those resonance structures? Well, that's a resonance structure, right? And so that actually makes that more stable. Anytime you have a resonance structure, that's going to act to stabilize it. Okay? So anytime you can draw resonance structures, that means you have that extra little bit of stability. So a little bit lower energy than normally would be. Okay? And by a little bit, I mean actually a lot. It can be way lower energy if there's enough resonance stabilization and they're stable resonance structures. They have low energies in themselves. Anyways, an interesting side note to this is that resonance structure means this is actually also a reactive location. but it doesn't matter. Because you would have the double bond here if you did the resonance, and it would again be the alpha position 1 off, right? So there's no difference in this case. But that's a more advanced topic again. First start on getting down initiation, propagation, what are my stable ones? Okay? And then you can play with games like, you know, oh, resonance structure makes this a reactive site too. Okay. Did you guys want anything else on this, or you feel like you're good? Okay, fair enough. Yeah, it's one of those things.